Hi, welcome back to CS170. Let's just pick up where we left off before. We're on week 14. We're talking about various aspects of computer intelligence, or chapter 22 in the textbook. So we're here on Watson. So to build on what we talked about for the last lecture, we're talking about games like chess and Go. Um, and, basically those are different variations of like a computer learning the rules of the game and being able to define and crunch through all of the different paths that you can take uh, within that game and optimize based off of that. So when you go to, let's say, Watson and Jeopardy, so Watson's the computer, it's from IBM. And the game Jeopardy, you add extra dimension to this. So now you start stepping into things like natural language processing, and being able to understand the question that's being asked, right? Like, so when you play chess or Go, you kind of know what you have to do, right? Here's the rules of the game, and you just crunch through it, right? Of course, you have another player that you have to deal with. And there's more variations on that. Let's say you start playing multiplayer games, you start playing like poker or something like that. It does get more complicated, but they all don't have that extra dimension about understanding in a more open-ended sense, like what is the question being asked, and then formulating a response to that. Okay, so this is where this is kind of going to a next level, where if for those of you that don't know, like, so in Jeopardy, the way you look at things is you have to understand the question that's being asked, and then try to apply that to come up with an answer. Okay, so here, basically, you have a large database to help it with parsing English, right? So it's one of those type of things. It's almost like if you read up on the topic with like machine learning and stuff like that, in some cases, the machine is kind of teaching itself. But even if it is teaching itself, there's this idea of kind of tagging things. It's almost like in that group collaboration stuff that we talked about last week, where like the Mars rover is sending a whole bunch of pictures back to Earth, to tag various bits of information, which will help computers to understand what it is that it's looking at. A computer might look at a picture and really doesn't really know anything, right, other than it's a picture, right? Whereas like a human will look at the picture and say, oh, there's a picture of a rock, or there's a picture of like a riverbed or whatever it is, right? So things like tagging things, you guys might know about tagging from things like on your social media, and eventually the computer looks at all of this different universe of tagging, and develops an understanding and say, oh, every time I see something like this is probably a cat or whatever it is that you're tagging, right? So in a similar fashion, when you look at natural language processing, there is an aspect of it following certain algorithms to try to figure out what is the context and try to figure out the meaning of what it's seeing. But in other cases, it's also benefiting or getting feedback to help it understand what is it looking at, right? So there'll be certain exceptions or different things like that, which a human person would be looking to give it additional information or context so the computer can understand what it's looking at in the future. Okay. So once it understands the question, then it goes to its database to look at all of the different possible answers that match up to what it thinks the question is, and then packages it up into English to respond. Okay, so it's a multi-step process for a computer to play a game like Jeopardy, right? And Watson was one of those computers that was developed to do that. So it's sort of like a technical achievement to be able to successfully play and win at Jeopardy. Okay. So this is important. So this idea of unstructured input. So what does that mean? Unstructured input. So you can imagine like whatever we're kind of doing right now, you're kind of putting out a whole bunch of information, right? It's not really structured or anything like that versus like, let's say those Excel tables, those data sets that we're looking at, those are structured, right? You have all the records, and then across the top, you would have things to kind of say, oh, this is like an employee, this is their last name, this is their first name, this is their address that they live at, this is their salary, this is the region that they're in, like all that kind of stuff. That's considered like structured input. Unstructured input would be like me glomming a whole bunch of like web pages in and then trying to figure out what does all those things mean. Okay, so that's what it's looking at here, right? So you have encyclopedias, you have dictionaries, blogs, magazines, web pages, and whatnot. It's not really ordered in such a way so you can say, oh yeah, these are all the employee names or something like that, right? It has to kind of pull all that in and try to figure out what does that mean. So, this kind of just tries to give you an idea of like how big of a challenge this is. So for the Watson program to crunch through all these different things, if you did it, let's say on your home computer, it would take a couple hours to answer a Jeopardy question, okay? And sort of like what I talked about before, where you're talking about the chess program, where you're kind of processing through potentially a whole bunch of different configurations. This kind of implies a little bit more, than what it's actually doing. I mean, I'm not trying to downplay how big of an accomplishment it is to try to crunch through all these different things, but there are certain aspects of this. It's not just like, okay, here's all the web pages, here's all of your blogs and whatever, and all the unstructured input, then it crunches it in real time and then responds, right? It's not really doing it that way. What happens is that sort of like we talk about the internet very early on in this course, we talked about like web crawlers and stuff like that to build out your DNS entries. This would also go through a similar exercise. So you would pull in all of this input and basically, like I was saying, tagging information, you would order it, try to build different slices of this data so that you can easily access it later on. Some people may call it like caching the data, but whatever, you're basically prepping the data so it's easily accessed in the future. In the same way with the chess program, all those different configurations, it's not like it generates those configurations in real time, right? All of that stuff is kind of done well ahead of you playing a game. So then when you actually play the game, you actually are accessing stuff that's already been crunched, right? Pre-crunched, you can say, okay? But anyway, it's still a pretty big achievement in either case, right? And so, so this is, some indication of that to say, well, if you had to do this type of process and crunch through all of that data, even if it's pre-cache, you're taking a couple hours to answer a Jeopardy question, right? And that's the 3 steps. 1 is to understand what's the question being asked. 2 is to go get it and try to match it up to what it thinks is the right answer. And then create like a proper English response, right? So it's like a 3-step thing, okay? Okay, and so here's another thing. It's kind of similar when you talk about machine learning. You're basically trying to analyze, previous questions, right? So in this case, they were talking about researchers. They're looking at previous Jeopardy questions to do this thing, something what you would call a lexical answer type, or LAT, right? So similar to some of the stuff that we mentioned in the last lecture in terms of like the weighting, like positive or negative for like the different paths for like, let's say chess. and on the go, the computer kind of figured it out for itself. But there's this idea of weighting different things, right? And like I just mentioned earlier in this lecture, we're talking about tagging different things, right? So you're basically crunching through data. So part of like how a machine gets smarter, how a computer gets smarter, is basically crunching through data. It's learning, and then through that, it will assign, depending on what the outcome you're trying to achieve, it will assign a weighting to it and say, oh, okay, out of the 5, 10 different paths I can travel, this is the best path I can take to achieve the outcome I'm trying to achieve. So there's a weighting to it. So by similar token, when you look at, oh, I'm going to tag this to be a particular object so the computer can recognize it later, these researchers were mapping based on historical data, this idea of a lexical answer type. Okay, so that's the main thing. So remember at this point, lexical answer type. Okay, so you have this. They came up with different 2,500 LATs that they defined, and then 10% that they weren't quite sure how to put together explicit LAT. Okay, so this is basically, well, you say 10%, well, that would be 1 in 10 that Watson wouldn't understand what the LAT is. Okay. So this is just like a screen talking about how this particular topic about natural language processing, Watson has kind of leveraged this research into a commercial business, right? So they're doing different things for automation. You could be like a company that's taking in different things. It could be emails, it could be like just requests through the web page. It could be, like I was mentioning in the last lecture, chatbots. It could be like even over the phone, like voicemail. It could be a whole bunch of different ways that a company is receiving input from its customers or its commercial partners. And this idea of natural language processing is something that Watson, among other places, are developing to try to support businesses to do these different things. It could be different things like reading legal contracts, reading, all kinds of news articles, social media, and stuff like that, and then translating that into more structured information that whatever your use is or your purpose is to process that. So that's all falls under the category of natural language processing or NLP. Okay, and then you can see here talking about text analytics and whatnot. Okay, so this is kind of like the commercial outcome of what stuff like this that they've been doing. Okay, and then we have like the chatbots, right? Probably a lot of you seen it on the web pages. You do something, there'll be a chatbot pops up. Maybe you type in something and it searches like it's frequently asked questions or some other documentation. It might say, I don't have this. I'm going to refer you to like a real person for customer service. It's a number of different things. So you can see, here's the chatbot here. Let's say this is your phone. And then here's the natural language processing, right? And you'll have like maybe past interactions, like other people have asked similar types of questions maybe, and then your knowledge base. Oops, clicked on that by accident. So you have this knowledge base. It could be your frequently asked questions. It could be whatever they provide as your documentation that's indexed and saying, oh, if you're asking about this XYZ topic, this is some information you can look at. Okay. So these are just some examples that you see here. Okay, and I mentioned this in the last lecture, talking about how you can have Google call up the restaurant to make a reservation. I've actually used this a couple of times myself. Haven't had any problems with it. Yeah, I guess these days I'm not making too many restaurant reservations, but I've done it in the past. It seems to work out okay. Um, so I guess one of these I should try to see if I can listen to the other end of it. I'm I don't own a restaurant or anything, but uh, be curious to see how that interaction really is. Okay. But so here's that idea, right? So you have the AI, it makes the phone call, calls up the restaurant, and then you'll make a reservation, right? And it'll be able to handle things where like the person picks up the phone, says, hey, hold on a second. Then it'll sit there, it'll wait for a bit. And then when they come on, then they'll talk. And then the assistant is supposed to say, yeah, I'm calling to make a reservation, blah, blah, and things like that. So like I said, I haven't actually heard the interaction myself, but uh, that seems to be working out well. It seems to make the reservations for me when I've done it. Okay. So this is kind of like, well, okay, as far as we've come along, there are still times where it's not quite perfect. So it has come a long way. So they gave an example here for Watson. They talked about a airport, which was in the United States. And they said it's the largest airport named for a World War II hero and a second for a World War II battle, right? And so Watson came back with Toronto, and I think the answer was Chicago, supposed to be Chicago. Um, so you have a couple of situations like this, but for the most part, obviously it was good enough to win at Jeopardy. So it's still a pretty big accomplishment. Okay, so there's going to be next concept is the universality principle, which I'm going to pause here. I'm going to cut a new video for that one. Okay, thank you.